Welcome to my science class. With me here, we are actually looking at the topic called sound wave in science paper 1. So, as you may be aware, science paper 1 is specifically physics. Okay, so this is our new topic that we are looking at in physics. So, to be specific, this is sound wave. So, what is sound wave? Before we go any further, we would like to understand the main topic. Okay. So, sound wave is a longitudinal wave made of vibrations in air. Okay. So, sound wave is made up of what? Vibration. Okay. Then point two, when something makes a sound, it vibrates in air. It vibrates air particles which transmit sound through the air until it reaches our ears. Okay, so that is how sound uh, is being created. We are saying when something makes a sound, that means that particular thing, it has just vibrated. Okay, vibrates air particles. So it is air particles that vibrates for the sound to be created. Okay, which actually transmit sound into our ears. Then apart from that, we should also look at the properties of sound wave. Properties of a sound wave. One, a sound wave is a longitudinal wave. That is the first property of sound wave. In case a question may come to say, can you mention the properties of sound wave? So longitudinal wave is one of the what? Property of sound wave. So a sound wave is a longitudinal wave. Then two, particles do not move across the media, but only vibrate to and flow. So that is what usually happens in sound wave. The particles, just like the way particles are arranged in a solid state, okay, their particles are closely packed, and when it comes to movement, they don't move from one point to another, but instead they just vibrate. Okay, so that is what we are talking about. So particles do not move across the media, but only vibrate to move to and from. Okay, going, coming back, just vibrating. Okay, I'm sure I've made myself clear on that point. The sound wave is transmitted only by the vibration of particles of the medium. So we are talking about vibrations. So sound waves moves, okay, by what? By vibrations, or transmit by vibrations. That is property number two of a sound wave. Then three, it has regions of compression. These are slightly higher pressure areas. Compression, compressed. So it has a place where it is compressed. Okay, meaning here has been compressed there. There is high pressure. Okay, that's what it is. Then property number four, it has regions of rarefaction. It has regions of rarefaction. So what is this region? So these are slightly lower pressure areas. So there is no pressure of air. Okay. So therefore, you are going to see that there will be slightly light there. Okay. Why? Because there is no pressure. So it has two things there. We have regions of compression and regions of rarefaction. Okay. Then property number five. Sound wave do not travel in a vacuum. sound wave do not travel in a vacuum. So when we say a vacuum, what does that mean? Sound wave does not move in a place where there is no air. So a vacuum this is a place where air is not found in it. That is a vacuum. So sound wave doesn't move in a vacuum space. Why? Because sound wave depends on air particles. So where there is no air, sound wave do not actually move from one point to another. Okay, so we go to property number 6. The speed of sound wave increases with an increase in temperature. So that means when temperature has increased, even the sound wave will automatically increase. Okay, that's what that property means. Then we can go to property number 7. The sound wave travels faster in a denser media. It is fastest in solids, then liquids, and at least in gases. So sound wave moves very fast in a denser media. So when we say denser media, we are actually referring to materials like solid. Okay, for example, a metal. So in a metal, sound moves very fast. In fact, the fastest. Okay, as compared maybe to liquid in water. But again, in liquid, sound wave move faster. But in gas, doesn't move very fast because of air there. Okay, so for it to reach your ears, it takes long. Okay, so that is the property that we are talking about. Then apart from that, we are actually saying it is fattest in solids, just like as I alluded to. So solids fattest, then liquids, because we are saying sound wave move very fast in a denser medium. So these are mediums that we are talking about in which sound wave passes through, and at least in gases. So gases is the least among the 3 media that we have mentioned. Okay, then this is actually these are 7 properties of sound waves. So let us look at now the meters per second in each media. For example, sound wave in air moves at 340 meters per second. In 1 second, covers 340 meters. Then water is about 1,500 meters per second. So you have seen it is changing. In air, 340 meters per second. But water is about 1,500 meters per second. That's the speed. Then in grass, that is grass. Now we know the grass that we are talking about. Okay, so in that sound moves at this speed 5,000 meters per second. That is 5 kilometers per second in grass. That's the speed. Then in steel, now the metal itself, the solid, the real solid, the speed is at 5,940 meters per second. Okay, so that is the speed of sound. You have to master this. Very, very important. Okay, so now let us look at this figure which we have here, which is actually trying to talk about the properties of a sound wave. So we have this diagram, as you can see. What have you noticed here? Here we have the dark part, and here it's light. Here dark, here light, then here dark, light. Okay, you have seen. So here now it is actually telling us that where there is dark light, that is compression, because in the properties of sound wave we've talked about the rarefaction and compression. So the dark part is compression. Okay, so it has compression. Then the light part, that is rarefaction. So on rarefaction, the pressure there is low. Okay, then here the pressure is high. Okay, it is compressed just from the word itself. Just even here, we are talking about the same. Now, let us look at the direction of particles vibration. So the direction of particles vibration, the way they move particles, they will go this side, again they will come back. So no wonder why you are seeing the arrows, they are pulling each other. Okay, they don't go anywhere. In short, the particles just vibrate. Okay, in sound waves, they don't go from one point to another. No, they will just go, they come back, just like that. Okay, so this is the indication. Then we come to the other one, direction of travel of sound wave. Now the sound wave now is traveling, now is going. That's why it only has one pointing arrow. So meaning now the sound wave is moving. So the figure, I mean, to just simplify what is written here on the figure. So we are saying the figure above shows properties of sound wave. So this figure is actually showing the properties of sound wave. Okay. The dark areas are region of what? Compression. This is what I was saying. The dark area, region of compression. The light areas are regions of what? Rarefaction. Okay, so this is just an introduction of sound wave. I really appreciate for your attention and understanding. Please don't forget to subscribe to my YouTube channel, Pedagogy Learning with Mr. A Plus Zambia, for more exclusive videos. See you in the next class.